For years, whispers of a hidden world have echoed at the farthest reaches of our solar system, a ghostly presence tugging at distant icy bodies, shaping their paths in ways that defy the orderly chaos we expect. Far beyond the known planets, where sunlight fades to a feeble glow, a handful of frozen objects move in eerie unison, their orbits aligned as if guided by an unseen hand. This clustering, this silent choreography, is too precise to be mere chance. Something massive, something invisible is pulling the strings. For nearly a decade, astronomers have called it Planet 9, a world perhaps 5 to 10 times Earth's mass, lurking in the cosmic shadows so far from the Sun that it takes millennia to complete a single orbit. But now, a new chapter has begun. A faint speck, a candidate for this elusive planet, has been spotted in the vast darkness. The data is real, the object is there, but something's off. Its orbit doesn't match the predictions. Its behavior challenges everything we thought we knew. Is this the long-sought Planet 9, finally revealing itself? Or is it a stranger, a cosmic interloper that could rewrite the story of our solar system? Let's dive into the mystery and uncover what this discovery means. The journey began almost a decade ago when astronomers noticed something peculiar in the outer solar system. Beyond Neptune, where the Sun's influence wanes, a collection of icy bodies, known as extreme trans-Neptunian objects, were behaving in ways they shouldn't. These weren't comets or asteroids, but frozen relics drifting in the deep freeze of the Kuiper Belt and beyond. Their orbits weren't scattered, as you'd expect in a region so vast and chaotic. Instead, they were aligned, their paths tilted and stretched in a pattern that suggested a gravitational force was herding them. This wasn't the work of Neptune, nor any known planet. The clustering was too specific, too unlikely to be random. Calculations pointed to a massive object, perhaps 5 to 10 times Earth's mass, orbiting hundreds of times farther from the Sun than we are. This hypothetical world, dubbed Planet 9, would be a giant hiding in plain sight, its faint light drowned by distance and its slow crawl across the sky nearly impossible to detect. The idea wasn't a wild guess. It was grounded in math, in the way these distant objects moved as if tethered to something unseen. Telescopes turned to the skies, scouring the predicted regions. Old data was dusted off, analyzed with fresh eyes. The hunt was on, driven by the tantalizing possibility that our solar system held one last secret. But for years, nothing appeared. The skies stayed silent, and the mystery deepened. The evidence for Planet 9 wasn't just a single anomaly. It was a pattern that grew stronger with each new discovery. More extreme trans-Neptunian objects were found, and many shared the same strange alignment. Their orbits pointed in the same direction, their paths tilted in a way that screamed of a gravitational shepherd. Some even moved in retrograde, orbiting backward compared to the rest of the solar system. This wasn't normal. In a region so far from the Sun, where gravity's grip is weak, objects should wander freely, their paths randomized by billions of years of cosmic drift. Yet here they were, dancing in formation. The math was clear. A planet-sized object, orbiting perhaps 400 to 800 astronomical units away, could explain it all. Its gravity would sculpt these orbits, pulling objects into alignment over eons. The theory wasn't just elegant, it was compelling. It explained not only the clustering, but also the odd tilts of smaller bodies closer in, as if the entire outer solar system bore the fingerprints of this invisible giant. Astronomers ran simulations, building virtual solar systems with a hidden planet included. Time and again, the models matched the real data. The clustered orbits emerged naturally when a massive object was added. It felt like the answer was close, just out of reach. But the skies remained stubbornly empty, and doubt began to creep in. Not everyone was convinced. Science thrives on skepticism, and Planet 9 faced its share of challenges. Some argued the clustering wasn't real, or at least not as real as it seemed. The objects we'd found were few, discovered by telescopes that scanned only certain patches of sky at specific times. This could create a bias, like fishing in one corner of a lake and assuming the whole lake is the same. If you only look where the light shines, you only see what's there. Maybe the clustering was a mirage, a statistical fluke born of limited data. Others proposed alternative explanations. Could a massive disk of icy debris, acting like a gravitational soup, mimic the effects of a single planet? Or perhaps passing stars, billions of years ago, had nudged these objects into their strange paths. A few even suggested gravity itself might work differently at such vast distances, though most dismissed that idea as a stretch. These counter-theories weren't as clean as Planet 9, but they didn't require inventing a whole new world. Simulations tested these ideas too. Some showed that a disk of debris could partially explain the orbits, but it struggled to account for the full pattern. Passing stars could disrupt things, but only under specific conditions long ago. The Planet 9 hypothesis held strong because it was simple, elegant, and matched the data better than anything else. But without a direct sighting, it remained just that, a hypothesis, teetering on the edge of belief. The search grew relentless. Telescopes scanned the predicted regions, from the wide-field Pan-stars to the deep-seeing Subaru. Old data from infrared surveys, like the one from the 1980s and another from the 2000s, was combed through for faint, slow-moving dots. These surveys weren't built to find planets, but their infrared eyes could catch the faint heat of a distant world. Yet every search came up empty. The problem was scale. At 400 to 800 astronomical units, Planet 9 would be impossibly dim, reflecting only a whisper of sunlight. Its slow drift across the sky, taking weeks or months to show movement, meant it could hide in plain sight, mistaken for a star or galaxy. Software designed to spot fast-moving asteroids often missed such sluggish travelers. Still, hope persisted. Maybe Planet 9 had already been imaged, tucked away in an old dataset, mislabeled as noise. Astronomers dug deeper, analyzing thousands of faint specks. Some surveys, like the Dark Energy Survey, ruled out chunks of the predicted orbit. Others, like the Zwicky Transient Facility, narrowed the search by eliminating regions where nothing bright enough appeared. Each null result was progress, shrinking the map of where Planet 9 could hide. But as the years ticked by, the absence of a clear sighting weighed heavily. The theory held, the math worked, but the sky refused to yield its secret. Then, in early 2025, a breakthrough, or so it seemed. A team revisiting old infrared data from 2 decades apart spotted something extraordinary. A faint object, barely a blip, appeared in both datasets. It had moved, ever so slightly, over those 20 years. This was no star, no galaxy. It moved like something in our solar system, far beyond Neptune. The object's infrared signature was faint but consistent, with a cold, massive body, perhaps radiating the last of its formation heat. Excitement surged. Was this it? The long-awaited Planet 9, caught at last? Headlines buzzed. Speculations soared. But as astronomers analyzed the data, cracks appeared. The object's orbit was wrong. Wildly wrong. Planet 9 was predicted to follow a long elliptical path, tilted modestly against the solar system's plane. This object? Its orbit was tilted over 120 degrees, nearly perpendicular to everything else, and it moved in retrograde, backward against the solar system's flow. This wasn't just a quirk, it was a rebellion against the model. If this was Planet 9, the entire theory would need to be rewritten. The clustering of distant objects, the cornerstone of the hypothesis, wouldn't hold. This object didn't fit the pattern. It broke it. Yet its presence was undeniable. A massive body lurking where nothing so large should be. The discovery didn't solve the mystery, it deepened it. This strange object forced a reckoning. If it wasn't Planet 9, what was it? A rogue planet, captured from another star? A massive dwarf planet, sculpted by forces we don't yet understand? Its extreme orbit suggested a violent past, perhaps flung into place by a cosmic encounter long ago. Simulations showed that such orbits aren't impossible, but they're rare. A planet-sized body could be hurled into a tilted retrograde path by a close brush with a passing star in the solar system's youth, when our sun was still nestled in a stellar nursery. Alternatively, it could be a native object, kicked outward by a chaotic dance with the gas giants billions of years ago. But each explanation raised new questions. If this was a captured planet, how many others might be out there? If it was shaped by our own solar system, why didn't it match the predicted patterns? The object's existence suggested the outer solar system might be far more crowded, far stranger than we'd imagined. It wasn't just a single anomaly, it hinted at a hidden population of massive bodies, each with its own story. The discovery didn't confirm Planet 9, but it proved one thing. We've only scratched the surface of what's out there. Just as the infrared oddity shook the narrative, another discovery added fuel to the fire. In 2024, astronomers found a new trans-Neptunian object, catalogued as 2024 XR17. Its orbit was jaw-dropping, stretching nearly 1,800 astronomical units at its farthest point, dozens of times farther than the Pluto. This wasn't just distant, it was operating in a realm we barely comprehend. Its path was elongated, tilted and eccentric, the kind of orbit that screams of a massive gravitational influence. At first, it seemed like a gift to the Planet 9 hypothesis. Such extreme orbits were exactly what the theory predicted, the handiwork of a distant giant, nudging objects over millions of years. But as data poured in, the picture blurred. This object didn't align with the clustered orbits of the others. Its path was too independent, too misaligned to fit the pattern. Instead of bolstering the case for Planet 9, it complicated it. If every new object followed the predicted clustering, the theory would grow stronger. But 2024 XR17 was a rebel, a reminder that the outer solar system doesn't always play by our rules. Was it shaped by Planet 9 or something else entirely? The question hung in the air, unanswered. This new object sparked a broader debate. What if the clustering itself was an illusion? Some argued that our discoveries are biased by where we look and how we look. Telescopes scan specific regions at specific times with specific sensitivities. If we're only finding objects in certain alignments because that's where we're pointing, the pattern might be our own creation. This idea, called observational bias, gained traction. The more objects we found that didn't fit the Planet 9 model, like 2024 XR17, the more it seemed possible that the outer solar system was just a chaotic mess, not a neatly shepherded flock. Yet the original clustering remained, stubborn and statistically significant. The math still pointed to a massive object, even as outliers like this new discovery chipped away at certainty. It was a paradox. Every new find added data, but not clarity. The outer solar system was revealing itself to be a place of wild complexity, where every answer birthed 10 new questions. This wasn't a failure. It was a challenge, a call to look deeper, to rethink what we thought we knew. If Planet 9 exists, how did it end up so far out? The question is as compelling as the search itself. Planets don't form in the sparse, icy reaches beyond Neptune. The disk of dust and gas that birthed our solar system was too thin there, too spread out, to coalesce into something so massive. So where did this hypothetical giant come from? One possibility is that it was born closer in, near the gas giants like Jupiter or Saturn. In the solar system's chaotic infancy, planets jostled for position, their orbits unstable as they tugged and pulled on each other. A planet-sized body could have been flung outward in this gravitational melee, not escaping entirely, but settling into a distant, elongated orbit. Simulations show this isn't just plausible, it's common. In many models, early solar systems eject one or two planets into far-flung paths, some resembling the orbit predicted for Planet 9. But there's another, more exotic idea. What if Planet 9 isn't ours at all? Picture the young sun in a dense stellar cluster, surrounded by sibling stars, each forming its own planets. In that crowded nursery, a close pass could have allowed our sun to steal a planet from another star, capturing it into a wide, tilted orbit. This scenario, called planetary capture, isn't science fiction. Simulations suggest a 20% chance of such an event in the solar system's first 100 million years. A captured planet would explain the odd tilt and eccentricity of Planet 9's predicted orbit. It wouldn't match the flat, orderly plane of our native planets. Both ideas, ejection or capture, are plausible. They don't break physics. They just require a solar system born in chaos, shaped by chance encounters over billions of years. The discovery of the infrared candidate and objects like 2024 XR17 has shifted the conversation. If these aren't Planet 9, they still prove something profound. The outer solar system is alive with secrets. These objects, with their wild orbits and massive presence, suggest a region teeming with unseen worlds. Perhaps Planet 9 isn't a single planet, but part of a larger population of rogue bodies, each stirring the gravitational pot. This idea challenges the simplicity of the original hypothesis, but opens a door to something grander. What if the outer solar system is a graveyard of lost planets, captured wanderers, and scattered debris, all shaped by forces we're only beginning to understand? The clustering that sparked the Planet 9 hunt might be just one piece of a larger puzzle, a hint of a cosmic history far richer than we imagined. Each new object, whether it fits the model or not, is a clue, a fragment of a story written in orbits and gravity. The question isn't just whether Planet 9 exists, it's what else is out there, waiting to be found. The search for answers is reaching a critical moment. Past surveys have scoured the skies, ruling out vast regions where Planet 9 could hide. But the tools of the past were limited, their reach constrained by technology and time. Now a new era is dawning, A telescope in Chile, designed to map the entire southern sky, is poised to change the game. Its massive camera and wide-field vision can capture faint objects down to magnitudes far dimmer than previous surveys could manage. Night after night, it will scan the heavens, building a deep, continuous map of the sky over a decade. Unlike older telescopes, it's built to detect slow-moving objects, the kind that drift imperceptibly across months or years. If Planet 9 is out there, within 800 astronomical units and bright enough to reflect even a sliver of sunlight, this telescope should see it. Its sensitivity could catch a world as faint as magnitude 24, far beyond what earlier searches could achieve. But its power goes beyond detection. By imaging the same regions repeatedly, it will reveal motion, separating planets from the static backdrop of stars and galaxies. If Planet 9 is hiding in the southern sky, where models suggest it's most likely, this is our best chance to find it. What happens if this telescope finds nothing? That, too, is a revelation. A null result doesn't just mean Planet 9 isn't there. It means we've been looking in the wrong place, or for the wrong thing. Perhaps it's smaller, dimmer, or farther out than we thought. Perhaps its orbit is so eccentric, it's hiding in a region we haven't considered. Or perhaps the clustering that started this hunt is a mirage, a trick of limited data. But even that would be progress. Science thrives on ruling things out, on narrowing the possibilities until the truth emerges. Other efforts will aid the search too. Citizen scientists are combing through data, spotting patterns algorithms might miss. Future space telescopes, designed to map the cosmos, could refine our understanding of the outer solar system, sharpening the background against which Planet 9 might stand out. And there's always the chance that it's already been seen, tucked away in an old image, mislabeled as a star, or ignored as noise. The outer solar system is vast, cluttered with the light of distant galaxies and the dust of our own Milky Way. Finding one faint world in that chaos is like searching for a whisper in a storm. This moment feels like the edge of something monumental. The discovery of the infrared candidate, the strange orbit of 2024, XR17, and the looming power of new telescopes have brought us to a crossroads. If Planet 9 exists, we're closer than ever to finding it. Its gravitational fingerprints are still there, in the clustered orbits of distant objects, in the math that refuses to lie. But the outliers, the misaligned orbits, the unexpected discoveries, remind us how little we know. The outer solar system is a frontier, a place where our assumptions are tested and our imaginations stretched. Whether Planet 9 is real or not, the search for it has already revealed a cosmos more complex, more mysterious than we ever dreamed. It's not just about finding a planet, it's about understanding our place in the universe. Every new object, every faint dot in the sky, is a piece of that puzzle. And as we stand on the brink of discovery, one truth shines clear. The solar system still holds secrets, and we're only beginning to unravel them.